Hello, everyone, and welcome back to Casual Vibers. I'm Yahya, and we were talking about Cursor and how to set up projects and how to set up rules and to use Cursor and the vibe coding to the best of the Cursor and LLM ability. I realized there has been a long time since the last time, but I've been busy creating pipelines and making a streamlined video making structure. So I hope that I'd be able to make videos more often and quicker. For this session, I'm going to talk about Git and GitHub and version control in general. This is pretty important because Cursor and LLMs can make mistakes and develop very fast. So if you cannot basically make a track of what they're doing, then you get lost. They get lost as well. And that's pretty important. At the same time, even for in the scientific context, we work 1, 2, 3, 4 years or even more on a project, and we test many things one after the other. I used to have a journal, and I would written different ways that I tried approaching a solution. But right now, with Cursor, with coding, and with everything like that, probably the best way, instead of having a written journal, would be to make the code and the computation that we do and the solution that we try as a version control. So without any further delay, let's get to it. But what we want to do here is first, let's understand why version control is important. And we will do a hands-on here. So we will set up your GitHub account if you haven't have a GitHub account before. We will review essential Git operations, and then we will review how you can use forks and issues and pull requests. And then we will try to have like a Git with VS Code and with GitHub Desktop. And then we will go about what is good to do and not good to do with Git and commit messages and so on and so forth. Okay. So basically, like in this journey that we have together, we're going to talk about the foundations in 20 minutes. We will practice about 25 minutes, and we will talk about the integrations to your workflow in the last 5 minutes. So first question is why we need to do version control and why it is actually a must-have in the academic environment. It doesn't matter if you write essays or if you write code or anything like that. As long as you work on academic products that can be written and are written, it is very good to have version control. You see, like that's happened actually to me from a file that I had 5, 6 years ago, but this is happening to many that I know, which would say, "Whoa, we had my analysis working perfectly, but now nothing is working. I don't know what changed or what happened, and I cannot track it." So what we usually do is we add a suffix. We did underscore final, underscore real, underscore comment by the advisor. Sometimes we have cloud as version control. And then when something bad happened, I did it also before GitHub. If something bad has happened, then we do go and get a snapshot back from Dropbox or basically Google Drive. Let me make sure I am on meeting mode. So then making sure we are, where is the focus? And sometimes you email the files to your advisor or email to yourself. That's actually a way of tracking. And sometimes we just trust ourselves to remember what has changed. I think this is not okay because we have 1,000 things on our mind and it is hard to keep track of everything. Basically, think of having a digital lab notebook. And as we document every experiment and record, any documentation for ethical considerations, we want to make it in a way that we can reproduce our results and others can follow as well, because that's the aim of the science, that people can benefit from it if they read our work. We can have a digital lab notebook, and at the same time, we can actually have that digital lab notebook as a Git version control, because we can write documents as Markdown text files with nice formats, nice plots and everything, and we can track our progress. I have lab minutes and meeting minutes with my director and PI all in GitHub as versions, and I add like different lines to it every time. And with that, we can record what's changed, why we changed an action. We can go and experiment on its course of action. And then if that worked out, we just basically merge it into our main pipeline. If it didn't work out, we just leave it there and archive it. And it basically provides a way for us to track our progress and also to make sure that our results are reproducible. So what we want to do here is to make sure that our documentation has rigor and our work can be followed. So we need to make sure that your future self can understand what happened in 6 months or after you graduate, or when you want to publish, or when a reviewer asks you about something. Also a common platform, so the collaboration can happen. People can contribute to the work, extend it, and use it from other places in the world. And we also need to make sure that our work is reproducible. Fortunately, many journals are asking for it. So hopefully we are ready and prepared. For the PIs, it is usually best if we have something like that, because when the student graduates, we do not need to chase them and ask them about what they did with their code and how they did it. And probably if you are a graduate student as well, it is good for you because you just move on and forget about everything. Okay, about some fundamentals. Git is not GitHub. It is a little different. So Git is a version control system that actually lives on your computer. You can have it on your PC, on your server, anywhere that you have, but it is just like an instance of version control. It tracks files and changes to the files. It works offline. It has command line tool, and it is pretty good with that. As you can see, like probably like an analogy is to have Word document, but have the track changes on. The good thing with Git is that it doesn't confuse or freeze when the changes are too much. It just handles them. Git, on the other hand, is a server that hosts files, Git version control files. It runs in the cloud. You can share your repositories and you can collaborate. So if there's an issue with a repository of the code, you can open issues and you can ask questions from the author or the researcher. It has a web interface. It has command line tools. It has like GitHub Desktop and everything like that. So you can assume it is like a Google Drive for your documents, but here is for Git. A probably common Git workflow with having a remote, which is GitHub, is something like this. Basically, we are working on code, and then when we are satisfied with the development at some stage, we add it. So we type git add, and that becomes the staging area. So the changes are staged. And then from that, if we are sure, we commit with a good, helpful message. And at the local repo, it becomes permanent. There is a permanent record of what we did. When we do push, the changes are pushed to our remote repository, for example, on GitHub. If we do not want to stage, we can do like edit and do other stuff and then redo before staging. We can changes as well. But then if there are things that probably others contributed to the remote repo and we want to just update our working directory, we do git pull, and that copies those changes from the remote to our working directory. So what we want to do here is to understand that we need to have additional layers after just saving. We do not want to overwrite our previous version or just have one version, the latest version there. We want to know how we got there. We want to make sure that we can do major changes. We can explain why the changes happened. And we want to track every file and everything there. So just not saving, staging, and then committing. We are tracking everything that is happening in our project. So as there is no free lunch anywhere, and after setting like saving, probably there's always a save, like an additional stage that you can always ask yourself, what did I do in this commit, in this changes, and how I can describe it for myself in 6 months, how good I can describe it concisely and very shortly in a way that I can track it if I need to go back to it. Repository is a project folder that the Git is tracking. Basically, there's a version control installed. It's just a simple code folder, but when you initialize Git there, it becomes like a Git repository. When you commit, you make a snapshot of your entire project at a specific point, and you add a description, and you can also add collaborators, so on and so forth. Branch is basically a parallel of your project. So basically creating a different reality of that project, if you want to say that, and to try new ideas without harming your main development branch. Merging means when you have another branch and you're satisfied with the changes, then you basically bring all those changes and those experimental work back to main. That becomes your main pipeline. This is something like basically looking at how development works. Basically, you have some initial analysis, probably some data cleaning, and then you have some hypothesis which experiment method would work, which you try with probably like the first 2 days or first 2 weeks, you try method A, and the method A results, it didn't work. So you leave it there, you make another branch. So this is like the branch A of method experiment 1 or experiment A, and then you have the second one, experiment method B. And then you tried that, and then you see that that worked actually. And then so you merge it into main here, like with this commit. Each of these nodes basically are commits that we have in time. So you make 2 of them for method A, that doesn't work. And then you try to make another 2 for method B, and that works. So you merge it into main, and then you go and publish your results. In reality, there are much more commits there, but at the same time, probably, hopefully you get the idea. Usually, like, as you can see, that main branch is stable, the code that always works, and the experiment branches are those that you are testing your hypotheses. And when you have a successful merge, then you have, again, like a main branch with more features. The first repository, if you haven't made it yet. So I'm going to do a hands-on here. We want to go and set up our GitHub account. Let me find something that is helpful for us here. No, not this one. Which one? Probably this one. Oh, it should be here. Sorry about that. So I'm going to go to, but let's go on. So let's have this in here and follow that. Okay, let's go to github.com. And let's sign up. So you can sign up with Google. I like in my original, like with my main account, I think that is easier. But then I'm gonna do this. So I'm gonna create like a fake account. Then probably like a strong password. The username, let's make it casual. Sorry, if we can write fibers. And then our region, you can set where that you want. And then, okay, is not available. Casual fibers. Okay, can we do it? Cool fibers. Probably. Okay, because we're very cool, of course. So let's do that now. Let's create the account. Of course, like with everything crawling, it just takes some time because it is basically like it just wants to prevent any bots to create a lot of. Okay, even a new day, it does not work. So what I probably will do is I'm gonna change this because for some reason I cannot do this. Let's try a real thing and see as that works. Let's see if it understands it. See? So yeah, I think it understands what is like a phone number and what is not a phone number. So what is like a hide my email number and what is not a hide my email number. So basically when I use the real one, it just did it. So I think, yeah, it's good. It's good in understanding that. iCloud.com. Okay, so let's copy this password. It's okay that you saw it anyways. I'm gonna change it before. Yes, update the password. So let's make this out of this guy. Okay. So what we're being here? So we chose a username. It is called Vibers, and then username. Yeah. So basically, if you are doing this with your institutional account, which I did with my usual account, then you can go to the education.github.com and verify your account based on your institution or school, or if like you are doing an educational adventure as a teacher or student. And then you get unlimited private repositories, you get GitHub Copilot access, you get your have to your own GitHub portfolio, the website. Everyone can get it, but then at the same time, you can have your source code private, keep some private stuff there, but then you have a facing, like a public facing website there as well. There are other stuff like you can get API access that is like more advanced, but you can get API access that is actually pretty nice and neat for doing API calls and scraping information from GitHub when you have a pro account. Otherwise, you get a ceiling for API questions and queries to GitHub pretty fast. While I check if everything is correct and working, I think we're at a good step here. So we can move forward. So here it is. I'm going to block this thing because I don't know what that is. And I'm going to make this as a focus in the meeting. So then nobody comes back again. So let's create this part, which is basically a research project. And then we would do a brief project summary and we'll make it private, initialize it with README, and then move on for this. The difference between public and private is that the private is just for you and anyone you invite. Otherwise, everyone can see it and then basically make comments or, I don't know, steal your ideas. I think that's might be pretty stupid, but at the same time, sometimes the idea is like really timely. So you want to just first develop it in a way that it just conveys better before make it public. You can always change and switch between these two. So let's do this. I just want to copy this to make sure that we have this in here. We go probably the plus sign and then new repository, and then say my research project description, a test project for the features of the GitHub Git and GitHub version control. So basically, you saw that it needed a couple of days for me to understand what is happening. Basically, you cannot do it with. It is hard to do it with to create an account with a fake or a disposable email account. So let's initialize with git me, and then you can see that, for example, if it is a Python project, the git ignore for Python is like the temporary files, package files that are being added. So there is a git ignore there. Usually, if you want to do, I don't know, the open source one, you do like a BSD, but at the same time, Apache and Creative Commons are good as well. I go with BSD. So it is pretty easy, and then it also retains some authorship as well. And that's it. That's like the project that we have already. There is license, there is README, which is just my research project, and description here. You can see the description is also here. We're going to work on this, the rest of this project. It says MIT, but yeah, MIT sometimes is hard to do. But it is basically we need they basically make you should make when you have this basically you make sure that they should make sure that there is like your name or basically is included. So basically you retain some at least ownership in some sense, not ownership, but like the credit of the work that you've done before. So I think BSD3 is a good one, good free research. Going back, so you can see that the repository structure usually like it is something like this, as you will have like some root files like license and README and sometimes packages and git ignore and others. So requirements is basically the packaging of what is required for this repository to run and install. Sometimes like you have PyProject if it's a Python. Git ignore is like the files that doesn't need to be added. Here, for example, for Python, you can see that there's a long list for it. And that should not be added basically, like PyCache, like the cache files, things that gets added when you install like egg files, AGG files. And then you usually have data. You might have data. You might have scripts. If you have source files, then there should be an src directory. Then there might be notebooks that you run through and you experiment. And if you have documents and figures, so on and so forth, you can do this. README is usually required in a way of a good practice to make sure that you describe what is this project about, how it is structured, how you can make it forward. So now that we have this project running on our repo on a GitHub, then we want to start working on it as a on our local computer. So there are 3 ways to clone, and I can basically make this as with a terminal. It's a good practice to have a Git folder that basically you put all of your repositories there, so you know where everything is, and then you try to work on a new repository one by one there. But overall, here is, you can do git clone and other stuff. So what I do is I have it on my documents. So basically I do cd, let me load up a little larger. So I have it under documents and then git for the ease of use. So if I do this, it doesn't work with the cool libraries because I need to add my credentials here. So cool libraries. It doesn't work for sure. Oh, sorry, the copy didn't work. Great. And you can. That did work. Okay. Now we have a problem. Okay, so probably then this is public. That's why. But if I change that, I forgot. So if I make this, if I go to setting and then change it to my visibility to private, then this wouldn't run again. So if I do git pull again, then so I need to go to my my research project and then git fetch, for example. It cannot, repository not found, so you cannot find it anymore. But then you can basically add your credentials here. Another approach, but Git is installed with Mac, and you can install it with package managers like Homebrew. Homebrew is this one. Probably I need to do a brew, brew.sh. Basically, I need to have probably a separate video to talk about Homebrew, why it is needed, and how to manage it. It's pretty handy for Mac users. So if you do not have it, go install it, copy this line, and then just copy and paste it in your terminal. So go to terminal and just paste it here. I have it, so I don't need it. But I think you can basically, if you do not have it on Mac, just install Homebrew and then install Git from that. Otherwise, it should be good. For Windows, you can install a Git installer and then use that. One other way is to download GH. So let me see if to download GH, and which is GitHub interface. So here, let's try and have it here. So GH basically is the GitHub CLI, and then you can log in easily, and then you can browse. You can use the repo command, which is here command, and then you can clone and you can push and you can pull. You can create issues and pull requests and add many things with GH. I highly recommend that as well. One other thing you can do is download GitHub Desktop. So that's actually also a cool thing. So how it works is basically it just gives you a private, a GUI interface that helps you with navigating. Yeah, you just try to move it, but if you do not move it, it just lives in your download space. But if you want to move it to your applications and then work out of it. So you can clone. We did clone, so we do not need that, but at the same time, let's move on. Okay. Can we just cancel? I really want to cancel and I cannot cancel. Let's try this. Okay. Let's create a new Git and do a test and create a repository. Okay, so you can add a local repository. So what was that? It was here. It is right. You should have at least one Git and then let's find it from. Sorry, it's just live coding is always difficult. So anyways, we're live doing things. So this and then, would you like to create a repository? No. So let's try it then. So you can see that I have a lot of things here in my research project. Probably I needed the full path. Okay. So now, because it is logged in as me on here, doesn't matter that what I did, or if it's public or private, it just shows that. And then when you go to history, it just shows like what commits, like the commits that happened. At the same time, it shows that if there are other commits, if I change anything locally, then it will show up and help me commit it to main. So just basically save it and then add a message and then push it to, and then basically make a record on my local repository and then push it to main. So when I commit it, it's just local again, but then it will change from the fetch to push. And then when we push, then it works something like that. The other one is to use VS Code. And for that, probably like it's good to have a new window in here. And you can basically open here, and then here, probably like my research project, and then open. And you will see that files coming here. And then there is like this part that under source control, you can basically see what happened before it's on the graph. And then if there's any change, you can do this. And for that change, you can basically, I can show you that, I don't know. So probably like having a new file here. Oh, welcome. And tag along. And then if you can see that this is going to show up here and actually show up on my GitHub Desktop as well. See? So anywhere I can commit, even here, either here or here. So it's update with a new line within invite, and then I can commit here. And then you can see that it also reflects there. So you can push. And when you push, it goes in here. Sorry, not this one. Just GitHub. And then probably like here. And then you can see that it is here as well. Okay, that's about it. So we cloned right now, and we saw what happens with this and how we can manage it. So what is like our daily workflow? For people who are, I don't know, taking notes, you can fire up like your repository and make notes underneath it as a Markdown or as a simple text, doesn't really matter. The reason that we're using Markdown, not Word documents, is that because Markdowns and YAMLs and simple text is just text, it is really easy to handle version control in a sense that you can manage what changed every day and each day, like different lines that are changed, different words in a sentence that changed. So you can manage the whole control on that. Docx is actually a zip file, is an archive with many files and several files inside. So it's hard to manage it. So basically, it's hard to version control and see what changed from the beginning to one day to the other. So let me fire up this. So here, Git status should be your friend status. Everything is clean. I think we can just basically write something on readme. And then like here, let's test, for example. And then when you do Git status now, see like there is something modified, and then you can do whatever that you want. We can do Git reset. So then anything that is here unstaged, you can reset that, or you can just modify that. Okay. Then something when it is nice and done, you add git add, and then it goes to the staging area. Then you commit with a meaningful message, and it goes to your local repository. And then when you push, it goes to remote. So remember, basically using Git status every time before committing or before pulling is very important because it shows if your working tree is clean before you starting doing anything. We can run this and see even like here. So again, we did that. So let me clear here. So let me do Git status here and see like there is a change here that on readme. And then if you want to see what exactly is happening on readme, it's saying like basically welcome and tag along was removed, and then basically welcome tag along plus the let's start was added. If you want to close it, you just like do a colon and Q. And then you can do also like see like what is happening. So if you do git log, it shows like things that are here. If you do git log online as the git log one line or online. So if you do, it is gonna be so it's gonna just show the last one, basically one line per commit. So it shows like what happened in every commit, and like it shows that like this commit is on track with head that is like in the origin, and basically this is local on main, and it is also on origin on main. So it is good and updated. Okay. So basically we can do this. If you have a specific file to add, you mention those files after add. If you want to save everything inside this within this directory, you just add and dot, and then you make the commit that's -m. So basically, let's do git add and then readme, and then git commit -m, and then you can add the message test how to add to me, and then that's it. And then if you remembered something, so we can do git commit. So write that and git add this, and then we can do git commit. Oh, sorry, amend with 2 of these. Did I? Yeah. Screwed it up. Okay, so it just asks, please enter commit message for you. Yeah. Okay, so this is just commit I. If you want to, this is like a Vim-like environment. So if you want to type or change, you should press I, so you can go to insert mode with exclamation. Okay, so then you do this and you write it, and then you do WQ. I really much. Close it. Okay, done. So oops. Okay, then we can do this one line thing again. Okay, so you can see that this one was the one that we had it, but then when we amended, we also updated the message we shouldn't have probably, but now it is test. So the thing that was in the text document didn't work correctly, but the amendment with the new thing that was added was working. So it is that. So then we should just git push. Come on. Should this write correctly? Oops, because it is not working, because it is a private and our Git doesn't have our login. Yeah, in something push here. And it pushes. If you want to add your credentials, it is good to use git auth. And then you can see that there is flags here, auth, login on GitHub, and then HTTPS, and then with the web browser. And if you press enter, you can just sign in with that, and then you can authorize it, and then you're done. And then you can also git auth again. One of the items is setup git. So if we do that, auth, and then setup git, it will set up git hopefully. So if I do git fetch, see, like now it worked basically. Or let's do git status online, or git fetch origin. Yeah, worked. But just before it was giving errors. I want to just try and see if it works. Yes, on the main branch. So now it is basically working because it can fetch from the main branch and on the origin, despite it is a private. So UseGH is pretty nice. We saw git push and pull, and then when you want to pull from a specific branch and also merge it, then you basically merge it from origin. Origin is like your remote, and then the main is the main branch. Okay. So what you should choose as a message for commits is should not be vague, like fix stuff. I updated it, or some changes and even more changes, or just like some characters. So instead, you can say what happened there. So if there is a change in the stats, or if a method was changed, or a pipeline was updated with something, or a typo, and that's actually quite important, because whenever like you go back and want to go back to your history, then you can understand what happened at each stage while looking at the commit message. So I think that's actually quite important. It helped me a lot, and sometimes like actually screwed me over a lot more times, because at the beginning of my career, I wasn't very good with the messages. So basically the rule is to use this and that this commit will, and that's how you add the message. And it is interesting because you see that it is basically using a gerund. It's not in past tense or anything. So it's just like a neutral format because it is adding this sentence, completing this sentence. So it's fixing, is adding the will fix, will add, will blah blah. You might add exactly like something like this, and I think it's going to be a good practice to have a meaningful information. You will see that sometimes people have like something like this fix, or for example, a chore if something is that you just need to manually change it, or if there is a feature, then you have a feat, and then basically add the whole thing. So add, for example, like it's going to be a feature. So for example, add stats to the processing pipeline, something like that. Anyways, okay. The reason that people may use and you would find GitHub Desktop pretty good is mainly because we are not familiar with the command line interface in the beginning, and it's fine. Actually, it's pretty okay, especially if you're used to MATLAB and you're not used to the command line and VS Code and other stuff. But I think along the way, 1, 2, 3, 4 years along the way, you're going to find out that the command line and terminal is a really nice thing, and it's not as hard to do. The other good things is that you can see pretty fast and easy what was changed, and then you can also see the history of everything. So you can see what was changed, what was added, what was removed, and then you can basically do many things here. You can do new branch, you can push pull, even you could create pull requests, this pre-review request. So you can do it and even create pull requests. It just goes to the repository itself. You can also choose the command line for doing pushing, pulling, and everything. But when you want to do visualization, then you use GitHub Desktop. But right now, to be honest, I use Visual Studio Code for that as well, because basically it is GitHub Desktop on a steroid. There are a couple things that will make your life easier if you know about it. And that's like when you forgot to add it to commits, you just add it and then amend it and then add no edits. And you're going to see like it's going to just get added to the previous commit, and it is fine. If you do not add the no edit, then you need to basically change the message or add to the message. If you have committed sensitive data, it is very important to remove it. You cannot just delete it because it will always remain in the history. If it could be identifiable data, or it could be API keys, license keys. These are really important that you do not commit them. The best way to not commit them is to add it to git ignore. We just discussed what git ignore is, and you add them there. Sometimes people make a secret file like .secrets or .environment, and then they make sure that it is in git ignore. So if it is just staged, you do git reset and it just becomes out of the staging, and then you can just not adding it. Or if it is in the last commit, when you do reset and then you do self and head -1, basically head like tilde1, this will remove the last commit, and then you can just basically stage without that file, stage it and then commit it. If you want to see what is happening again, like here we have this. I think we need to clear again. So if you do git show, it shows what happened in the last commit. And then if you want to see what happened, what is the difference between this and the last commit, you can do this as well. It is a similar result, basically. Let's talk about and switch to collaboration features. That includes how we can code together and resolve conflicts, or if we want to add a feature, how we can do that moving forward. One important thing here is to fork a repository. When you want to make a copy of a repository, basically you can fork it instead of making a copy without citations. It is very similar to what we do when we want to cite work or code. The advantage of that is that when you do this fork, first you give credit to the original developer. At the same time, if you have any change or improvement, you can actually make the change and then make a pull request or PR and then add it to the original repository in the code base. That way you also get credit for contributing to that code base as well. And this is one of the very nice ways for getting recognition and becoming a collaborator on larger projects and established ones. I am part of several initiatives, including EG Lab, brain imaging data structure and others, and everything usually works with forking and then making a PR, requesting a review, and then merging into the main repository. So basically, as I mentioned, there are several scenarios that can help. For example, if you want to modify a method and then you want to use it for your own analysis, if you want to customize a tool, if you want to make a version of your code that is simpler and easier for students to follow, or if you want to make sure that everything that you are using from another paper are following exactly their footsteps. So you fork it and start working on that. Basically, like as very similar to what we have as citations and working with citations, or we have like situations that we want to clone a work or fork a work. So we would fork if we want to contribute back to the original repository, make significant changes, or we want to actually make public credits for the improvements that we make, or claim credits, or we want to contribute to the original and give credits to those who made the original efforts. And basically like extend the existing research tools and make a derivative work from that. But if you want to just work with the tool as is and just make some modifications and you don't want to share it, or you don't want to make something out of it, or it is very temporary, so you just want to, for example, like making a tutorial or just follow a tutorial, just clone it and it is fine to use that as well. Another very nice way of collaboration is using issues. And I can actually like start with the GitHub and show you here like how the forking MPR works. So, and we're going to talk about this later as well, but you can see that if I can make it bigger or larger. So this is like issues, and the pull requests are here. At the same time, you can also always, you cannot fork your own repository, but if I am like another person, I can fork this as well from here. But we're going to talk about this later. So if there is a bug, in the code, or you have a feature to request, or actually there are questions about how things are working, you can have an issue, post an issue, and usually like the maintainers or the developers are nice to respond, especially like when there's a bug report. At the same time, some larger repositories, they have a discussion section as well. I think we do not have it here, but we can basically activate the discussion section here from settings. So sometimes like the questions go and discussions goes into the discussion section, which is very similar to issues, but it is just like for further discussion and quick questions, and even for planning. I want to add probably a couple more points. Even if you are a solo researcher, it is good to create issues for yourself to keep track of your development. So a good rule of thumb is that if you have a feature to enhance, or even feature to develop, or if there's a bug, just make an issue for a feature enhancement or a feature improvement, or just creating a new feature, or just having a bug fixed, then create a new branch, start developing on that branch to make that feature or fix that bug, and then create a PR. So the pull request, and then when tests pass and we're satisfied, you just make the PR and merge it into main. Similarly, if you have a collaborative research, this is even more important because we need to respect others' work as well, and we should avoid committing directly into main branch because others are also working off of it, and then making PRs and requests basically is the best way to go to make sure that others' efforts are not also being affected unexpectedly, basically. That's exactly like the reason that we need to do a request. So basically, as I mentioned, when you create a branch, which probably is based on an issue that was created or a plan or project that was created before, you create a branch and then you do a pull request. On the larger projects, or if you have additional tests that you would do edge cases, you can have continuous integration and continuous tests and workflows that I'm going to talk about it in a later video, but you can have automated reviews basically and automated checks. And also you can request reviews if you have a collaborator to do that review for you as well. And if it is approved, then you basically merge into main, or if it is not approved or tests are failing, then you revise the code and then you move forward. That is actually like a very nice way of quality control of your work. And that is very much needed for working together and making sure that things are approachable, and our improvement will not break our established methods and methodologies and approaches and pipelines. So that would be very nice to do that, even for publications. So publications are usually right now in LaTeX, or basically there's a text that can be converted into like a Google Doc, and so basically you can work on it off of a Markdown or a LaTeX text, and that can be really easily and very efficiently be handled and tracked with with the repositories and pull request features. It is very nice to handle that, especially like if you get used to this GitHub and version control, then you can keep track of the development of the paper as well, and having new figures and pictures and so on and so forth. So let's try exactly like having this, and let's make something like that. Let's go to terminal. Terminal. Yes. So if you remember, we were at documents, and then Git, and then my research project. So then we can basically do a checkout. So create a branch, and dash B means like a new branch basically, and it's that test. So then let's make sure that we have this. So we should make sure that you are a stat test and that. So I have this additional like basically theme that is allowing me to do that. So then we can have the analysis here. Let's make an analysis. So BI analysis, and then import pandas, and then we do something for that. And then this is the basic stat analysis. And then let's just type in Go, and then git commit -m, and then add basic analysis file, and git commit, and then git push. That -u thing, it means that is actually required when we do not have a remote branch. So -u means like in the origin, create this branch and sync it with this branch. And that's how it works. So let's see, like there is a new branch that was created and it is in sync with this. So now let's go to the GitHub and then create a pull request. So if we go to GitHub here, let me just pull it up and make it here. So you can see that it says, oh, something was created. So we can go add to pull request and do this, or we can just open the pull request. You can assign yourself, for example, and you can add like labels. And it is good to have labels because if you have this really long project, then you can actually search for labels, and it is pretty nice. So then you can say this PR as stats, a common stats in an example. You create a pull request, and if there are any tests that are working, then you will see that here as well be running. Otherwise, then you can basically merge. And let me just merge it so you can see that basically confirm the merge. And then when you merge, it's basically another commit here. So it says, for example, the last commit is merging of the pull request 1, and now you have analysis.py in your main branch as well. Fantastic. Okay, so next is that what can we do for a good research strategy and making sure that we are doing the best practices for having a successful GitHub research repository. So we need to make sure that we have a main stable branch, and then we basically infer further development of like features into independent branches. So basically, if there's a data cleaning required, then that is its own project and branch. If there's a stats required, that could be another one that is coming from starting, for example, after data cleaning. And then the good thing is when you do this, then multiple students or collaborators can start working together. For example, data cleaning is something blocking all of this analyses, but at the same time, when the cleaning happened and it is complete, then you might be able to basically start both stats and visualization in parallel. And that is something that is very useful with having multiple branches and multiple people working together. And then when you use the PR, basically the system, if there is any problems and conflicts, people will be able to resolve them, because like the comparison that is being done during a PR process helps us to merge these conflicts and make a resolution out of them. Okay, so now I think that we're done almost with most of the things that we wanted to talk about in this video. I'm going to go for like about 10 slides or so, a little deeper dives on what tools and integrations that we can do with GitHub and then Git and GitHub, and that could be just like for reference for later. The first one that we talked about is having a GH, GitHub CLI, which is actually, as I mentioned earlier, it is very useful for making like repositories, cloning repositories, adding issues, and even like using GitHub API basically for following up on issues and very well maintained repositories. So this is basically the good thing with CLIs is that you always are in your terminal, and the advantage of that is that you can code it. So you can basically automate this process much faster. And with LLMs, who can do tool use, you can use GitHub CLI to make commits, make PRs, and make issues and make corrections, and so on and so forth, like very easily with LLM, because now they know how to use GitHub CLI and they can just interact in terminal, and it is quite fascinating. So what you can do, and I think we described this, basically is the same research workflow that we just saw. You just do a login, and then you create your new repository, and then you create like a branch, and then from the branch, you create a PR, and see how easy it is. The body can be as long as you want, or the title can be different, and then you can also add labels here. So dash label or dash assign, you can assign people as well. There are actually very rich flags that you can use. And then when you have, for example, continuous integration tests, you can do GitHub PR status. So if it is passing or it is approved, you can know as well. And also you can also get comments of people here as well. And this is like, again, with using of like LLMs, this is like a very, very nice thing to do, because then LLMs actually can read the comments that people are making and then make adjustment to the code themselves. You do not need to even write it. You just can write, hey, in the VS Code Copilot, for example, hey, look at the comments that I got for this PR, and then make adjustment to the code based on these comments, or just summarize them, and I will decide which one to address, or something similar. You can make also aliases for your common workflows. For example, if it is just creating PR or creating like a common bug reports or daily reports, then you can have some aliases for that as well. Sorry about that. So the other thing that we saw, I think before, is the VS Code and how you can do VS Code. And I think I can do like let me see. So this is like actually like the code that I have for this, like the equivalent of this presentation. So that is actually like this one, like how I brainstorm or how I have planning for different stuff. This is like basically my overall workflow here. Do I have a README for this? Or I don't. That's pretty bad. So I need to add a README here. But you can see that for the previous one, for example, I have a transcript. It is all in Markdown. And then for this one, I have this code that this presentation as an HTML, and everything is working. And then if you want to see what's changed, for example, you can see that if you go on this source control tab, and then you press on a specific commit on a specific file, you can see that the changes show up here. You can see that things show up that are changed, and it is pretty nice to see this view. And basically, that's the reason I mentioned that you do not need to have the GitHub Desktop anymore, because if you work with VS Code, that's like the whole thing. With branch switching and other stuff, that's actually pretty easy. You usually get this here underneath. It is very small, sorry about that. But if you click on the main here, you can see that you can create branch or check out a branch, or you see that there is a branch that is main on the remote branches, and there is a local branches as well. So you can just create branches here as well, and it's pretty easy. Similarly, when you create a PR, then like the PR also shows up underneath as well. And then you can basically start working on the PR as well. So it is pretty straightforward to do that. It's good to have Git lens and Git history and Git pull request and Git graph. So this is a graph actually that you are seeing. I think you probably have the Git lens here. If you have the educational account, Git lens will be free, and you can basically use it pretty well. And especially like for larger projects, it shows very nicely what's added, how much it is added or it is removed. And that's actually pretty nice to do. And basically you can change the branches or the repositories. If you have multiple repositories here, then you can change them here as well. And it is actually like quite handy here. But if you do not have a education or pro account, then I wouldn't probably bother. Again, like very similar to the recommendation they had from before, you can basically use VS Code, very similar to the GitHub Desktop. You can use a VS Code for daily Git operations, making diffs, and then looking at the differentials of the code. And then you can also use command line when you need some conflict resolution or amendment or other stuff that you cannot do. Another very important thing is, which touched upon earlier, is having a git ignore. Basically, there are files that are secret or just too large. It's basically GitHub prevents any file larger than 100 megabytes to be uploaded. So if it is large, or if it has sensitive information, or if it is just something that is generated and it can be regenerated again, then you basically add them to ignore. And this means that any CSV is ignored, or H5, for example. And this means that the figure directory is ignored. And this is a specific file that is ignored. So I think that makes sense if you look at it. And as a rule of thumb, never commit raw data or password or API key. For raw data and data storage, there is like a large LFS, basically, or I think large file storage or something like that. And we're going to talk about that and data lad and similar approaches later on, but then still do not use that with GitHub. So Git LFS is for handling large files, and that's because it cannot handle very large files. And sometimes you need to make another way of handling that. And sometimes you need another repository, another disk to handle them. So that's like how LFS comes in. And basically what it does is that creates a record of that file into your Git repository, but actually points it to a separate repository, separate file or cloud, which can be like Amazon S3, it can be actually your own Google Drive or OneDrive. It can be a NAS in your network. So a network attached storage or anything else. And basically you can work off of that. That's the way you just install LFS, and then you ask to track, for example, files, or you can ask to track files that are larger than some amount, like 10 megabytes. And it does that for you as well. Then when you add it, you can add it as normal. And when you commit, it just actually gets pushed to that LFS storage. The file itself will not be added to the repository. A signature of it will be added to the repository. I mentioned that you can use data lad, which is basically wrapper over LFS, and it makes it a little easier to handle. That requires its own video, and we're going to talk about that. Once you're satisfied with your research code and it seems that it is ready to share, you make releases. And that means that sometimes you freeze the code and make a snapshot, and you make it that to report it at a certain version of the code, and that is like a release. Release helps with creating the snapshot in time and in code. Then you can get a DOI for it, and then you can also make a milestone out of that as well, because then you achieved something that is a release and then has a version, and then later on you can compare one release to the next release and so on and so forth. Usually there are semantic versioning. So if there's a minor versioning, you have basically after one decimal, if it is a bug fix, it is the second decimal, so 0.1, for example. And if it's a major release that changes the behavior that or breaks the code or breaks previous use, basically you move from 1.0 to, for example, 2.0. Sometimes some products also do date-based versioning. That is also a common practice. One other perk for GitHub is GitHub Pages. Basically, you can get your user account.github.io, which helps with making your personal profile page, a personal website, and then you can share your CV, your projects, and even your lab, and it can be free. It is like a free resource. You can use it as a landing page for your project as well. That's actually quite easy to set up. It is just, you go to settings, and then you basically go to pages and you make GitHub Pages here. I cannot do that here because I'm on a free version. And for GitHub Pages to be available, my repository should be public. This repository has a log here, so it is public. I can make it a GitHub Pages page if I make it public. If the code doesn't have any HTML or it doesn't have any basically engine to run a server for GitHub page, then it just shows a README here, and that's that easy. If you have good README, then probably you can do that and make the README available as a GitHub page. I can see that this is like that. If you have basically a specific repository to share, you can make the GitHub Pages available. Then that's basically what you can do. It will be available under your username, github.io/, and that can be used for supplement materials, additional figures, whatever that you want to have, and you can just add it to README, and then you can share it with everyone. And also, if you make a release out of that with the previous, then you can also get a Zenodo DOI for it. So it's always saved as a snapshot. Okay, now we are just like in the last stretch. Okay, so we are in the last stretch, and thank you for bearing with me on all of this, and probably over multiple days. So what we're going to do for an academic workflow, basically for every time that you start, especially like for collaborative projects, make sure that you do a git status and git pull and git fetch. Make sure that your working tree is up to date with the cloud, with your GitHub. Make sure that you have a focused commit. And basically, if you are changing multiple files within the day and you are making different features work, then you make different specific, like they call it atomic commits, meaning that for each feature that you're adding or for each feature that you're changing, you just make a separate commit. It is okay for one file to commit every portion that is related to each other, every portion that basically an atomic you change within one commit and then do another commit and so on and so forth. Make sure that you push regularly the changes into the cloud, and then make sure that you use branches. So the main branch is stable and only will be like you merge into main after enough testing. Make sure to have milestones, and you can use milestone page from the repository page, or you can have tasks in the issue or the PR and have a checkboxes there that shows that what you have accomplished. And then once you have everything ready, and you can version it and tag it, and then you can make it available with the DOI. So basically make sure that you always commit and commit often and write very good messages for your commits. Some things that you need to make sure not to do is that you should ignore huge files. Huge files will be a pain. And then if it becomes part of your history of Git, there will be one copy of that always in your Git history. And that is very important. So you should never commit a huge file. If that happened, then you should go back and remove that history of that file from all your commit histories. And believe me, that's a pain to do. Avoid vague commits and commit messages, like fixed stuff doesn't make sense. So make sure that you have some things meaningful there. Sometimes even when you are in a stat analysis, the commit should not be add stats or add method, because when you look at the commit, you can list the commit messages, not the files by itself. So if the commit message says add, for example, Bonferroni to stats, that is complete, then you can get something from it. But if it is like add a feature, and then basically you think that, oh, I know that it is from stats because I see it is a commit to the stats function. You cannot see it later when you just list the commits and you want to find the commits from the history, basically the commit history. Make sure you always back up to a remote, because sometimes happens that you work on multiple machines or multiple people are working then, or unfortunately, like something happens to your local machine, then you'll lose all of your work. Make sure that you do not ignore branches. Do not work basically on your main branch. Save the main branch for only main use and not development use, basically. Some practice is that if something is being used regularly, we can have like a main branch, another one that is dev branch. So it's like a beta branch, and that should be very important. And you can develop out of that branch if you have just one feature to develop, and then you can always merge the dev into main and then create another dev branch and working off of them. Make sure that you document the setup and installation. It is very simple, because if you come back 6 months later, the chances are very high that you forget how the installation worked, especially if you move to a new machine, get a new laptop, change labs, or another person wants to use your code. They do not know how to make installation dependencies work for your repository. Starting simple and making regularly for small edits is a very good practice for success, and making good code. Sure that you follow the error messages that Git gives you and the conflicts it has, and then sure that you read what gives back and try to fix it, because the good thing with Git is that you can reverse almost everything. There is almost nothing that is irreversible. Don't be afraid, use it, because it's very old and there's a lot of documentation for it. The other approach, which is very nice for academia, people want to get credit for their work and become authors, gets and commits track how much contribution each person made. If there are people that are not technical, they can still use GitHub Desktop and work toward that. You can share your work while it is in private. You can add collaborators into your private GitHub repository. And then also you can use that as a tool for training the students and basically blocking them from merging the new branch, but creating a PR, and then you go and review their work, and then you merge the branch into the main. So avoiding catastrophe in your basically production or your research workflow. As I mentioned, never commit API keys, passwords, or anything like that. into Git history. Git histories always remain there. The Git itself is a Git repository. So even the first commits from 1970 or something, it is there, still. So you can also go back and look at the first commits that are there. So it is important not to share these things. Make sure that if it is large data sets, to use Git LFS, and make sure that all the pipelines have reproducibility as like in mind, basically with helps and readmes and markdown file and instructions. And you need to make sure that for sure, basically like as a reminder, you need to make sure that any data sharing that you do is in compliance with your institution and also the publication that you're using. So to learn more, don't hesitate to go to GitHub Learning Lab, Learning Hub, or using like ProGitBook or other advisors on your campus to get more information on how to use Git and GitHub. Actually, librarians are very good in managing Git, and they are very professional in that. Also, later on, don't hesitate to learn about Git hooks. And Git hooks means basically things that you can do before commits or after commits basically are happening. If sometimes like you want to version something or bump up the version or check for grammar or something like that, then you can use Git hooks to run a script, for example. GitHub Actions is for continuous integration and testing things and publishing, for example, a website after an edit or adding a post, for example. And then we can do advanced branching with workflows, with multiple work trees, so on and so forth. And also we talked about data lab and how we can version large data sets efficiently in a Git and version control way. So as a thing to do in the following week, just start one of your research projects as a Git repository and push it up. And if you want to, you can just share it as a comment. I promise to check all of your repositories and then start them for you. So you will get your first star from me if you comment your repository underneath this video. Okay, so we covered how to create a GitHub account, apply for GitHub Education and Pro benefits and account. We how to install Git and GitHub CLI, and how to create the first repository with a real project. We made the first commit and we made the first push, and we create the first PR as well. For the next week or month or however that you want to do, try to convert one of your projects into version control and start practice with branching and making sure that you are following the best practices for version control. Make sure that you have a git ignore and ignoring large files and sensitive data as well. Remember that version control is a basic skill. It's like knowing math. So basically, like when you know it and you start practicing it daily, then you will see that it will multiply on all of your projects, and you will have a very useful tool in your toolbox for even more complex and multi-institutional, multidisciplinary projects that you will do later on. Thank you. I really appreciate you watching this video and walking through this journey with me. Next week, I most probably will talk about VS Code and the extensions that probably we all need to have, including like the extensions for Python, the grammar checking, and the late workshop extension to write scientific papers and even CVs in LaTeX within. Thanks a lot and have a great day.